exponential decay, which is given by the function y equals a times the quantity 1 minus r raised to the t power. A is your starting value, starting / initial value. One minus r is going to be your decay factor. T is going to be period and time. T is the time period. And R right there is going to be your rate of decay. Now you have, we'll talk about, the y-intercept. So for the y-intercept, for these functions, or this equation, it's going to be 0, a. And if we pay attention to the note for the last 3 days, there actually is no x-intercept. No x-intercept. It does not cross the x-axis. No x. It tries to, but it can't. Now we are going to compare the two exponential growth versus decay. So exponential growth, you have, y equals a times b to the x, where b is greater than 1. And for decay, you have y equals a times b to the x, where b is greater than 0, but it is less than 1. So the reason is, if you multiply things that are greater than 1, they get bigger, even if it's slowly. And even, and if you multiply by things that are less than 1, they get smaller. And we would, do stuff, manipulations like this if we were back in the classroom, to show you, hey, this is what happens. So gets bigger / grows. This function, the values gets smaller / decays, hence why they have their names, growth versus decay. And exponential functions, they have they increase or decrease. So they get bigger, they get small very quickly. Write a rule for the functions. Remember that the basic rule for exponential functions is y equals a times b to the x, where a is your starting value. All right, so a is the starting value. B is the rate. So I know from here that 0, 1 is my starting value. And for me to go from 1 to 1/5, I have to multiply by 1/5. For me to go from 5 to 1 multiplied by 1/5. For me to get from 1/5 to 1/25, I have to multiply by 1/5. So it looks like my B equals 1/5. I put my things together, so Y equals 1. You don't have to put the 1 in here. 1/5 raised to the X. Second one. Take a look at my points. It looks like I got point here, 0, 1. Then this looks like 2. Looks like it's -1, 2. For me to get from 2 to 1, I have to multiply by 1/2 or divide by 2. Those are the divided by 2 and multiplied by 1/2 is the same thing. So I know that my rate is going to be 1/2. I know my starting value is 0, 1 because when x is 0, y is 1. I know this is an exponential function because of the shape of it. It has that curved L-looking shape. So then my function is going to be y equals 1/2 to the x. Now this guy right here. So my starting value is 0, 5. That's my initial value. My y-intercept, my initial, that's what it is. It looks like this guy crosses here, which is 2, 1, 2. But I'm not entirely sure. And then from there, 0.8. So then what could I divide by? How would I get from there to there? I don't know. I could make a little mini table and think out the calculations. All right, let's see. I got 5. I got 2, and then I'll go up 0.8. Get from here to here, I need to multiply by 2/5. Let's test it out. 5 times 2 divided by 5. Yeah. 5 times 2 divided by 5 times 2 divided by 5. Yeah. And I have to do the same thing. So then 2 times 2/5 will get me 0.8. And if that's the case, then my rate is going to be, or my B value will be 2/5. And my starting value is going to be 0, 5. Therefore, because that's my y-intercept, or my starting value, therefore y equals 5 times 2/5 to the x. Number 4, indoor water park. An indoor water park had a decline in attendance from 2000 to 2005. The attendance in 2000 was 18,000. Each year for the next 5 years, the attendance decreased by 5.5%. A. Write a function that models the attendance since 2000. B. What is what was the attendance in 2005. So for us to do this, we need to remember that we need to use the exponential decay formula, y equals a times quantity 1 minus r to the t. So r equals 5.5, and we know that from that being the rate of decrease, or the rate of decay. Now, we also know that the starting attendance was 18,000. Okay. So that's how we're going to write our growth model. So y equals 18,000 times the quantity 1 minus, well, again, this is a percent. We need to change it to a decimal. And we do that by moving the decimal 2 places to the left. 2.055. The t, which equals 18,000 times 0.945 to the t, which is what y equals. I'll put the y equals there, that way it looks cleaner. Then now, what was attendance in 2005? So again, you have to realize that this is the function that starts since the year 2000. So 2000 will be the year 0, which means therefore that t is going to equal 5. Since you want, to start at the year 2000 will be 0, 2005 will be 5 years from there. So y equals 18,000 times 0.945 raised to the 5th power. And then we get 13,000 565.367, or 13,565 and 367 thousandths of a person. But you can't have, you can't have like 0.367 of a person. So the attendance is 13,565 people in 2005. Last one. You buy a used car for $12,000. It depreciates at a rate of 15% per year. Find the value of the car for the given year. First thing we need to do, write in a function or an equation that'll help us determine this. So y equals a times the quantity 1 minus r to the t. My starting value, a equals 12,000, because that's how much you buy it for. Our rate is 15%, which becomes 0.15. Now I input my values in, and therefore I get y equals 12,000 times 85 hundredths to the t. Now I just plug it in. So for this one, I will get 12,000 times 0.85 to the 1, 12,000 times 0.85 to the 3, 12,000 times 0.85 to the 5th power. And let's see what I get. 12,000 times 0.85 to the 1. 12,000 times 0.85 to the 3. 12,000 times 0.85 to the 5. So the first one, I get 10,200. The second one, I get $7,369.50. And for the third one, I get $5,324.46. And that's it. I hope you guys all have a beautiful and wonderful day. If you have any questions, comments, or concerns, please show up to office hours. If you have any questions about office hours, the link is in the description. I hope you have a beautiful and wonderful day. Mr. Othman is out. Bye.